Hello, my name is Jayesh Sharma, and I am a senior from the Science and Engineering Magnet in Dallas, Texas. Today, my group and I will elaborate on our conceptual design of a colonial base on the moon. The idea of space exploration has fascinated the human race for many years. While space research and exploration extended far into the galaxy, humans themselves have only traveled as far as the moon. Despite the immense amount of knowledge and technology developed by man, humans have barely scratched the surface of the vast expanses of even just our galaxy. However, in the future it may become necessary, and even vital, for humans to travel farther and farther into space and perhaps even to colonize other parts of our solar system and beyond. The purpose of this project is to design a self-sustainable extraterrestrial colony that could be inhabited by humans should the colonization of space become possible or necessary in the future. So why the moon? Last year we developed our theory on a Mars base, but we did it on the assumption that a base on the moon had already been developed and tested. The moon gives us a testing ground to understand the needs that a true permanent base on independent planets would require. Given the moon's dependency on Earth's gravity, the ambition that we must have going into the moon is to remain unattached, while realizing our findings and decisions on the moon will guide the future of our expansion into deep space.
Our structure is made up of a unit of 4 domes, 2 agricultural domes, 1 animal dome, and 1 tree dome. We chose to build these domes with a material called ethylene tetrafluoroethylene, or ETFE. It has many favorable structural qualities, such as being highly resistive, anti-corrosive, and very sturdy. It also has useful practical qualities, such as being self-cleaning and recyclable. The colony is powered by solar panels, which are connected to an energy storage system, so we have energy to use when the sun isn't out.
The oxygen in our colony is cycling throughout our facility because of the airtight locks at the entrances to the structure. Oxygen is collected from trees and pumped throughout the colony, and then CO2 is cycled back to the trees for the continuation of photosynthesis. One of the biggest issues concerning a colony on the moon is water. Although drinking water requirements for humans is less in space, it is still of vital importance for not only drinking, but farming and animals as well. One of the benefits of the moon in this process is the existence of ice in the deep polar craters and regolith. However, this source is not directly usable. For this reason, we propose in our colony to use the Sabatier reaction, a process that converts hydrogen and carbon dioxide at high temperatures and in the presence of a catalyst to create methane and water. For our hydrogen source, we can both use the ice from the poles separated into oxygen and hydrogen through electrolysis, and the recycling of methane through pyrolysis to make the process sustainable. This leads us to the air supply system. Oxygen from the electrolysis reaction could be used to resupply the air to the colony, and the CO2 waste from animals and humans could go back into the reaction. Plants also provide a good source of O2. Next, we dealt with the issue of waste. First of all, conservation is of number 1 importance. Through a very small use of water and a recycling process, we can preserve the water and nutrients we have. Any liquid waste can be sent through a system called the WRS, Waste Recycling System, currently in use at the International Space Station. Solid waste will be recycled at our waste treatment plant and either used for fertilizer, for the crops, or assimilated back into the use of the colony in new forms.
After clean drinking water, our next concern is getting enough nutrients for the colonists. It takes less energy to produce a plant-based diet than a meat-heavy one, so a plant-based diet is more sustainable. We have 4 above-ground domes, each housing a farm and powered by a segment of solar panels.
A crucial aspect of every human-inhabited environment is the space in which people live. The space directly affects the morale and well-being of the colonists, and if the physical and mental health of the colonists is neglected, it could jeopardize the productivity and stability of the colony. With our first colonists, the numerous changes they will experience from living on the moon could induce stress, anxiety, and loneliness. Since we have a small population, we counteract this by designing an area where scientific research and advancement can occur right next to everyday community activities. With a recreational center which houses a small track, a weight room, and an open space for playing sports, we can account for the physical fitness of the colonists. Furthermore, with a hub where they can socialize, talk about any problems they are experiencing, or just catch up with a friend, we've arranged a place for the colonists where they are able to recuperate and relax their minds. By providing these facilities, we can minimize possible sources of dissatisfaction and allow the colonists to focus and contribute to other parts of the colony.
Now that we've addressed basic practical needs such as food, water, air, and shelter, we must also address the social needs of a 1,000-person colony. Cooperation is imperative to the success of the colony, therefore there must be a system of government in place to ensure the colony runs smoothly and efficiently. The colony will have several departments dedicated to research, engineering, and maintaining stability, each of which shall appoint a representative to the Council of Department Heads. This council will be responsible for resolving conflict, maintaining order and stability, and making important decisions for the colony concerning goals, methods, and policy. As both department and governmental heads, the council members will also be responsible for the delegation of work to other colonists for the science, social, and policy goals of the colony.
After discussing the needs of a colony, and even furthering our concept of societal factors, there may be a low priority level for anything else. However, the future is perhaps the most exciting part of this colony, as the future is the reason this colony is so significant. The opportunities that a colony on the moon brings are limitless. So many questions about space that we were unable to answer on Earth will be answered, such as how the environment is affected on other planets due to their different atmospheric pressures and different periods of revolution around the sun. Also, it will give us much more information on how the new environment around humans will affect their metabolisms and body shape. With extended periods of darkness and a much smaller force of gravity acting on human bodies, will future generations be a pale, translucent-skinned race that have a relatively lean frame with perhaps new proportions and eye shape? How will the new environment affect the natural timelines in our bodies? Will the new day-night cycle affect our sleeping patterns significantly? These unknowns up to this point were impossible to test in controlled synthetic environments created on Earth. The answers to these questions would solve many of the mysteries of space and opens up its entirety to human exploration. With this not being a mere settlement where people live out their lives, it allows for preparations for an increasingly more rich society and unique culture. The research undertaken in this science-based colony paves the way for increasing diversity among the colonists, transforming this colony into a civilization. Our future lies in the success of this colony. Our overuse of Earth's resources are giving us a limited amount of time left on our mother planet. The time to adapt to other planets and utilize all of the knowledge of the past millennia to take advantage of available resources has arrived. The need to move on starts with humanity's first interstellar colony on the moon. The knowledge we gain here on the moon will guide us not towards only our first permanent base on Mars, but the future and the rest of our galaxy and beyond. Thank you, we are the SEM team.